hey, I'm a mid-career professional. I want to get into the AI engineering space. In the data science space, for example, it's like, hey, go find a data set, go practice your skill sets, and then see what you can package up at the end that's useful. What does that look like for that person?
I feel like you really need to understand application layer foundations before you start doing anything, which essentially are these things. Prompt engineering, really play with these LLMs and understand what they're good at and what they're bad at. Just use ChatGPT. You start realizing that there are a bunch of things that it is good at and it's not good at. Then learn about RAG. These 4 things should be really clear before you start building projects. Post that, I would always say build projects that solve your own pain points and scale them, right? If data science is all about taking a particular data set and building something predictive or building something grounded, I feel like AI is all about automating repetitive workflows. A very simple example is...
Let's talk about like an AI engineer. What does the day-to-day according to you looks like?
So I think in enterprises, if you are an AI engineer, the idea is this: someone's coming up with a business problem, and how can you make a good decision on what is your approach to solve that problem? You should have a really good understanding of what these usage paradigms are, what are the pros and cons. And I feel like an AI engineer, the role is to identify business problems and translate it to AI problems, and also identify evaluation metrics and translate it to business metrics and things like that. That's your role. And all the tools that you're using, all the usage paradigms you're using, it doesn't really matter.
Hello, everyone. We are excited to have another podcast with Aishwarya. Aishwarya is a Gen AI tech lead at Amazon in AWS, and we are excited to talk to her today. And I have my co-host, Hi Gwan, here. And hey, Aishwarya, hi. What's up?
Hey, Aishwarya, hi. Oh my God. I said that in my mind, and yeah.
Really everybody nice. Says that, so it's cool.
Yeah. Really nice to be a part of the podcast. I've been watching a few episodes, and pretty cool. You guys are doing great work, and yeah, I hope it'll be fun.
Yeah, it should be a really fun episode. Can't wait.
Yes. So Aishwarya, would love to understand. So to the world in LinkedIn, everyone knows Aishwarya as this content creator. And not just a regular content creator, I would say, because I love how much value you provide with your, the current trends in LLMs and Gen AI. And you're also working full time in Amazon, and you're also a lecturer and a professor in some areas. Would love to understand all these different aspects of your current professional life. Yeah.
Yeah. So most of the time I kind of work for AWS. So that's like my 9-to-5 job. And what I do at AWS is work at this org called Generative AI Innovation Center, where we use AWS Bedrock, which is a Gen AI platform, right? It's a managed service where AWS clients can build solutions. We build those solutions for them. They come with a business problem to us, and we kind of design the entire thing. And I lead a team of applied scientists, solution architects, strategists, and all of these folks to design a solution for them, and also go at this entire process of iteration, experimentation, build a prototype, and then think of how it can go to production, scaling, evaluation, all this typical ML deployment lifecycle. So that's what I do on a daily basis. And that also kind of necessitates me to have a lot of this knowledge on generative AI, the trends, the models that are coming up. A lot of application layer knowledge, because we're kind of working with these models and building solutions and building applications. And that's when I started writing. I think I started writing maybe last Jan, because I had this new resolution that I made that I'll read 1 paper a day, because there were so many papers and I'm going to kind of keep up with research. And I thought, if I'm reading, might as well just write a bit about it. That would kind of rekindle my passion for writing. And then that blew up and opened up a bunch of other opportunities as well. And folks from Oxford reached out and said, will you be interested in teaching? Then I had a bunch of folks who said, maybe can you talk to us about AI strategy for a particular project that we're trying to do, or a enterprise problem that we're trying to solve. And that's like, okay, fine. I talk to these people and advise them on strategy. I'm also a researcher by heart. Like, I have been doing research for the past 9 years. I wrote my first research paper in 2015. 2014, 2015, yeah, 9 years. So I'm a person with too many passions and I get burnt out too many times. It's a process. I'm also still trying to prioritize and understand what I should be paying the most attention to. I do research with a bunch of professors and I basically advise students on their research journey. And that also helps me to keep up with research. So I feel like my unique perspective comes from that because on the one side, I'm talking with researchers who are working on state-of-the-art techniques. On the other, I'm applying that to enterprise use cases. So if I look at a research paper, I kind of can tell if this is something that can be translated into a use case or if it's something that's done on a very small data set and is not really useful or applicable in the big picture. And yeah, I feel like those all tied together and it's been good.
That's so cool. I mean, that's like the dream job for a lot of people, especially at this forefront of the whole AI movement, right? There's so many things I want to dig into. So one follow-up question, specifically on your work in the innovation lab at Amazon Web Services for your clients. What's one example of a project that they bring to your attention and want your expertise in advising them on?
We see a wide range of use cases, right? I think the most simplest use cases we've seen is to build some form of knowledge search and retrieval. Each of them have very unique ecosystems. Think of something like an employee chat portal or something like that, where you're not really looking at documentation. It's simple things, right? Like how many days of PTO do I have left and things like that. You don't have to do search and retrieval anymore. You can probably chat with your system. Those are very typical use cases we see until things like some folks want to understand, chat with their videos, like, knowledge discovery from videos and which can be used in use cases like surveillance and things like that. The other things are also code generation use cases. Think of platforms where data scientists use a lot of SQL. Can you kind of simplify that and reduce the amount of time it takes to onboard, right? If you have X number of databases, it takes a while for data scientists in these companies to kind of understand the ecosystem and all of that. Can you have like a system that would generate SQL and you can do some natural language interfacing with it? We've also worked with folks like NFL. Like NFL basically has live recordings of all these matches and you can draw insights using generative AI. And that was a pretty cool use case that was also public recently. A very wide range of use cases. And just in the past 1 year, I feel like a lot of enterprises that were not even using traditional AI because of the hype or because of all the talk that's happening, really want to explore and understand how they can simplify their workflows. So this is the first time I'm seeing such a diverse range of companies and verticals trying to apply AI in their use cases. I think recently we worked on this really cool use case with a company, with a legal tech company, right? More of a legal firm that had like thousands of PDFs and images of contracts and other documents that they wanted to parse into a structured format. And Anthropic Claude does a really cool job at that. Like you can pretty much throw in a bunch of different PDFs and it will digitalize that for you.
That's really cool. So it sounds like any sort of client could just come to you and be like, hey, Aishwarya, I have this business problem. Can you help me solve it with AI? Is it as high level as that for the most part?
Yes, but I have spoken to a bunch of leaders who also don't really understand what AI can or cannot do. So there are a lot of use cases that AI probably cannot solve very well at this point, or they're just cheaper ways of doing it. My expertise also lies in the fact that I really need to guide them and tell them that this is probably what you don't need generative AI for. This could just be a workflow and things like that, right? So yeah, they do come up with problems, but there are also constraints under which we would make a decision as to whether generative AI is the right solution for this.
Can you give an example of that, Aishwarya, where you think there's still people think AI could solve that problem, business problem for them, and you're like, no, this is still not a Gen AI thing, or it might not be the right solution for it?
I think a lot of these solutions that try to replace therapy and stuff like that with generative AI feels a little too far-fetched to me. One, because it's a very subjective thing, right? Different people react to different kind of therapies. And then I feel like as humans, we have this ability to be pretty sensitive to feedback. Just looking at someone's face, you kind of get some signals, and generative AI is not that sensitive, already in that space where we could solve very subjective things like therapy with AI. So again, a personal opinion, I feel like there are a bunch of startups who are already trying to do that. Where I've seen AI add a lot of value is in very objective tasks that require some form of knowledge search and retrieval. If something is documented very well and could be instead of a human having to analyze hundreds of thousands of documents or like databases, AI can make that simple. But wherever subjectivity comes into the picture, it becomes really hard to make a decision because humans have a lot more context of the world when they make decisions. And with AI or with models currently, I feel like we're not there yet. And the feedback loop is not completely closed with AI now, right? Because they're trained on a certain set of data. Then they interact with systems, and to retrain them again, it takes quite a while. You need to observe user interactions and then retrain them. And retraining at this point is pretty expensive. So AI systems are stateless at this point. They do not evolve. I feel like we can go to these use cases when AI systems are cheaper to train and easier to evolve. But at this point, we are still not there yet.
That makes a lot of sense. There's also the flip side of it. I think some people overcomplicate things as well. Hey, something that would be a straightforward if else kind of thing. And then they're like, hey, let me put some AI into this. But at the end of the day, it's just a Zapier integration. Okay, let me define step 1, 2, 3, 4, like super straightforward, nothing, no judgments needed anywhere. Then it's equivalent to using a nuclear bomb to kill an ant kind of thing. That's also one thing that I observed in the industry as well.
Yeah, I think sometimes there's pressure from the leadership as well. Where is the AI in your product? And people tend to jump onto this bandwagon. But even with my Maven course, I think that was the major intention, that I am somehow not very aligned with folks who say I want an AI first company and things like that. I feel like it puts emphasis on trying to push AI everywhere. I still think that most products and services are successful if you have a very problem first approach. What are the pain points, and is AI the right choice to bring in here? I have spoken to a bunch of clients in the past who come to us and go like, is there a way we could have agents here? One, agents are not what you're thinking it is. They're not a magic bullet that are going to solve everything. And two, you don't need agents here. If I talk to about 10 people about AI, 7 of them are talking about AI, and maybe only 3 of them or 2 of them really know anything apart from agents. They think agents are this new thing that has come up. And I asked them, do you know what RAG is? And they're like, no, what is RAG? But if you know what agents are without knowing what RAG is, then you need to go brush up your foundations, because that's pretty much not how systems are designed.
Yeah, just for our audience, could you actually define agents and RAGs for our audience?
And even maybe something that comes before that. What's the timeline, right? So you probably need to understand what LLMs are, what types do we have, and from there, yeah.
Sure. Essentially, all of this stems from deep learning or neural networks, which are basically models that have a bunch of parameters and update themselves. Almost think of them like tons of different switches within a software system that go on and off to make a decision. And then post that, we started going to neural networks that could understand language, that could process words. And back in 2015 or 16, RNNs or LSTMs were the popular neural networks for processing language. And then in 2017, someone came up and said, and folks from Google came up and said that RNNs are pretty slow because they're processing sentences word by word, and maybe we need parallel processing. And that's where the transformer architecture came up. And even then, we had language models. Language model is 2017, even before that thing, right? Even with RNNs and LSTMs, you could build language models. And language models are essentially models that understand and generate language. And then in 2017-18 is when OpenAI and other folks started saying that, okay, we have this transformer architecture. Now we can, just by stacking layers and layers in the encoder or in the decoder, we are able to get better performance just using the transformer architecture and making it bigger and bigger. And that's when we entered the large language model era, right?
So the era kind of started in 2019, if I remember.
I think GPT, the very first GPT, I don't know, it was in 2018. That was when researchers figured out that just by making these models huge, it seems like we're getting better performance, changing nothing but dumping tons of data and increasing the size. Just scaling it without any science innovation is also leading to better performance. GPT was the first one that made that up, right? And GPT also was one of the first models that was focusing on generation and not understanding. BERT as a model is a language understanding machine. It doesn't generate anything, but GPT took the other approach to say that we will also generate responses. But everything after that LLM era, right, where maybe 2020, 2021 models started getting much bigger. And in 2022, OpenAI came up with this UI, with this customer experience that was pretty seamless. Although it was still the same technology, or I believe so, because these are closed source models and I can't really say what they're doing on the inside. So that's when people started talking about large language models and all of that, right? But then in 2022 and 2023, people started realizing that, okay, this is something fancy and it's fun to use, but now how do I derive some ROI out of it? How do I put it into enterprises? And turns out that when you started trying to use LLMs in enterprise applications, they weren't as good because these are generalist machines, right? They've been trained on web data. And they're not, and again, that's when people start coming up with prompt engineering to optimize responses, to say that, okay, if I spoke a certain way, I'm getting better responses. But that still wasn't good for the enterprise, because every enterprise has a very unique way or a unique structure in which they organize their data. And that's when RAG became a thing. RAG is pretty much like open book.
It's somewhere the hallucinations came somewhere in between, right? Basically, the reason why you probably are not getting right answers, and hence we need other systems. Is that why RAG was also introduced?
That is true. So hallucinations were an issue, but I feel like, again, hallucination is this thing of large language models not being able to answer, or probably giving you false answers to questions just because they have been not trained on certain sets of data. But enterprise systems, even without hallucination, it's very obvious why LLMs cannot answer questions, because they just do not have the context
That makes sense.
required.
It's
right?
all private information that
Exactly.
enterprises hold within themselves, and the entire web data could probably give some, I don't know, generic contextual answers, but they wouldn't give an answer that's specific to their problem that sits in enterprise. Yeah.
Exactly. Back then, if you remember, even in 2023 or 2024, context sizes of LLMs, or basically the number of words that they can consume, was pretty low. It was somewhere around 32K tokens, 32,000 tokens. Tokens are, again, sub-words, words split into smaller parts, which LLMs kind of consume, right? So even at that point, RAG was really necessary, because even if you were an enterprise trying to say that I will dump in all the context required for you to answer the question, the LLMs were just not ready to handle so much context. And that's where RAG came up, where they said, okay, maybe chunk it down, chunk all the information you have, put it into a vector database, and pick up only the most relevant information for your query and provide an answer to that, right? It's pretty much open book question answering. Like, you ask a question and you try to pick up the most relevant information that is required for someone to answer the question, and just provide the answer. And then everything that we discuss in 2024 or later has been pretty much on the application layer, right?
Yeah.
RAG agents. Now, once enterprises started using RAG, they figured out that there are sometimes LLMs do not have to be called for everything. For instance, like simple calculations, or like generating code and executing it and things like that, right? And can you use other tools to do that? Like, an LLM can be a decision-making entity to kind of call tools that are pretty well known to do some things as compared to LLMs, right? If I ask for the weather, an LLM obviously cannot tell it because it's stateless and it doesn't have access to current information. So can I use a tool to do a web search and get that information? So that's when agentic kind of workflows picked up, where you use the LLM more as the brain or the decision making or the orchestration framework, and connect it to a bunch of other things. And then there's this multi-agent system where you say, oh, can different agents kind of converse with each other and arrive at a decision and stuff like that. But post this transformer era, 2023 and later, I haven't seen huge innovations in the model layer. There obviously have been a lot of innovations on, how you can change the attention to make it, faster, how you can improve the accuracy by a bit and stuff like that. But there have been a lot of innovations on the application layer, which is RAG, agents. Fine-tuning is also one space which is gaining a lot of momentum. Again, I would say that's that's come somewhere between application and the model layer. But these are pretty much the usage paradigms. And when you talk to folks who are AI engineers, they are working still at that level. The model is kind of abstracted from them. It's just an API that they're using.
I love that, you bring this entire context of agents and drag and all of this, right? So let's say, typically, let's talk about like an AI engineer. What does the day-to-day, according to you, looks like?
So I think in enterprises, if you are an AI engineer, the idea is this. Someone's coming up with a business problem, and how can you make a good decision on what is your approach to solve that problem? You should have a really good understanding of what these usage paradigms are, what are the pros and cons of each of these, right? A bunch of people that I've mentored always ask me, is LangGraph the best tool to use, or is CrewAI the better tool, and which vector database should I be using, and stuff like that. I feel like an AI engineer, the role is to identify business problems and translate it to AI problems, and also identify evaluation metrics and translate it to business metrics and things like that. That's your role, right? And all the tools that you're using, all the usage paradigms you're using, it doesn't really matter, and it differs from company to company. If you learn LangGraph today, there's a high chance that next year it's replaced by something else. Or if you go into a company like, say, at Bedrock, we don't use LangGraph, we use Bedrock agents. So it doesn't really matter what tools you're using. This capability to identify problems and translate them, kind of iterate over solutions. This example that I said, right, employee chatbot or something like that. That's the use case that a business is coming. Can you build a very simple solution, iterate, prototype, and then scale it and stuff? It's very similar to what a software engineer would do, but just the underlying API that you're using is actually a large language model. And there's some amount of non-deterministic nature that comes from using these models. Like software is very, deterministic. And you have to learn everything that comes with using this non-deterministic piece of software. And that is things like prompt engineering or hallucinations, or sycophancy is another thing that I've seen, which essentially is a problem with LLMs. They tend to agree with very opinionated people, right? If you say, this is wrong, what do you think about it? Most likely the LLM will say, yeah, I think this is wrong because, and it'll make up something.
I've done that.
So, yeah.
Same here.
Yeah. So I feel like as you use these LLMs more often, you can build solutions around them. And a good software engineer can also be a good AI engineer. You just need to pick up these AI paradigms and also just use it more often to understand the nuances about AI models. But otherwise, the underlying framework is pretty similar.
So if I summarize, AI engineer is like a software engineer who takes business problems and solves them as an AI problem. But the difference is that the AI problems are not as deterministic as software engineering problems are, and understand the AI paradigms around it and solves them, and eventually connect them to the business metrics to understand what was the positive and negative that you've solved for, if it helped or did not improve.
Yeah. That's the most concise way I put it in.
Yeah, that's awesome. I think what that also implies is having good judgment, having good domain expertise in certain fields is going to be the game-changing aspect of it, what sets them apart from a mediocre one. In the data world, we see the same thing. In the data science world, for example, Shravya, you've seen a whole bunch of these. If people are rigid in, hey, tell me what tool to use to solve this problem. If that's the question that they ask, then typically that's not someone who's as good as, hey, the actual tool doesn't matter. I need to understand what is the problem here so that I can ask a better question, for example, so that I can find out what that real thing is needed. So somebody who's listening or watching who doesn't want their jobs to be replaced, it's very important to be very analytical about certain problems, and that the world is getting more and more into this vague space because we have LLMs to help us make certain judgments and complete certain tasks, especially the repetitive ones.
Yeah, definitely. So, Aishwarya, I'm trying to piece through whatever you've said, right? And there's so many other questions that I have around it. The first question I have is, when we talk about AI engineers, who are all the people that surround these people? I can definitely see someone who's asking a question, like the person who is actually coming up with, hey, I have this business problem. Can you help me with this? And the AI engineer themselves, like you said, need to know if this is an AI problem or not. Who are these people? Are these like product managers? Are these like marketing folks? Like, who are these people? That's one. And who are the people that surround AI engineers that they interact with on a regular basis?
Yeah, I think the baseline here is also just the fact that AI engineer is a very umbrella term for a bunch of things, almost like a data scientist, right? In every
That's true.
different company, what a data scientist means is very different. I have worked in 3 teams in Amazon, and the meaning of applied scientist is very different in each of these 3 teams. So I think
So-
it heavily depends on the size of the company and how much of delegation there is to different people. At least the way it works, say clients that come to us is essentially there are folks from the leadership who have an idea that this is probably a repetitive work that we want to, or a knowledge work that we want AI to solve. And there are solution architects and AI strategists that work with that company to understand if this is a viable case for us. They basically understand their ecosystem, understand what data they have and all of that, and then they bring it to the applied scientists. Applied scientists are pretty much AI engineers, but I think the minor difference, at least for us, is the fact that we design solutions and think more in terms of strategy, evaluation metrics, and all of that. And the implementation or scaling, productionizing is done by machine learning engineers in the team. So these are folks who have like traditional software engineering expertise as well. And we are folks who kind of talk with research scientists and machine learning engineers. And also the strategy, solution architecture folks, and all of that to come up with a viable business problem and metrics for that. Again, I feel like the if you're really thinking of who these folks are who identify these problems, I feel like product managers also are folks who should be really
Product
on the
managers,
forefront
yes.
of this, right? Because I feel like AI is a very raw technology. It's almost like the cloud or the internet, and product managers are the folks who can think of really innovative customer experiences around it. Think of how you can make this into something valuable. My team specifically does not have any product managers, again, because of the way we operate, but I see a lot of value in a good product manager trying to at least understand the foundation of what AI can do so that they can innovate around the experiences.
That makes sense. Just a follow-up question on that, actually. Based on how you've seen and mentor other people, let's say like somebody wants to get into the AI engineering space, they want to be an applied scientist in your group, for example, what sort of like mistakes do you see the aspiring people kind of make, like whether that would be the direction of the skill sets that they acquire or perhaps maybe misconceptions that they have about the field? Can you share some things that you've seen on that side that can help our audience to go at the right direction?
I think there's a spectrum of people I've seen. On one end, there are people who are in this tutorial hell. They're constantly watching a ton of videos and imbibing everything that they see. On the other hand, there are people who are just hands-on implementing. They're going on doing a bunch of different projects, putting that on GitHub and not really understanding if this is a project that would be useful or does it solve a pain point. I feel like on that spectrum, you really need to meet at the middle and think of how much of theory I need in order to build use cases or build projects that could solve any enterprise problems, right? Especially if you're looking for a job, because having passion projects is fun, but then if it's not solving anybody's pain point, I feel like if I look at a resume with 100 different AI projects, and if someone can answer why they built it and can, customers really see some value in that, I will be more impressed with that rather than I just checked off a list of these projects. I've built a rack project, I've built an agentic project and stuff like that. So every time you're building something, really think of, can you really use this in the real world? And how do you kind of solve issues with that, right? As soon as you build a RAG pipeline, if you're a software engineer or if you're a machine learning engineer, regardless of which background you come from, because most likely people getting into AI have, some form of major previously. If you're a computer science major, people are also switching mid-career to AI. So my advice to all of them would be piggyback on the knowledge that you already have from whichever domain you're coming from and think of how this problem can become complex, right? For instance, the RAG pipeline I was talking about, there are cases in the enterprise where, document sizes are too huge or they have a particular structure. So how can you really think of the chunking methodologies for that? And sometimes in the enterprise, you have to make sure of access controls, because if your builder RAG system, probably everybody shouldn't have access to all the documents. So how do you build that? How do you enable guardrails for this? And let's say there are 1,000 requests coming in. How do you handle scaling this to these many customers? So whichever background you're from, I feel like you can always piggyback and then think of how this can translate to real use cases after you've built those small prototypes, right? And that would differentiate a good AI engineer applicant as compared to the one who's either just very heavy on theory or the one who's just going on building projects that would not create any impact.
Yeah, where would you suggest them to start in the context of hey, I'm a mid-career professional, I want to get into the AI engineering space. In the data science space, for example, it's like, hey, go find a data set, go practice your skill sets, and then see what you can package up at the end that's useful. What does that look like for that person?
I think following Aishwarya on LinkedIn comes first for them, but yeah.
Yeah, number one, follow Aishwarya. What's number two?
I feel like you really need to understand application layer foundations before you start doing anything, which essentially are these things, prompt engineering. Really play with these LLMs and understand what they're good at and what they're bad at. I feel like a lot of people jump into building projects without even having, spoken to LLMs. Like if you use LLMs in your daily activities, just use ChatGPT, you start realizing that there are a bunch of things that it is good at and it's not good at. So narrow down on prompt engineering, then learn about RAG, agents, and finetuning. These 4 things should be really clear before you start building projects. Post that, I would always say build projects that solve your own pain points and scale them, right? If data science is all about taking a particular data set and building something predictive or building something around it, I feel like AI is all about automating repetitive workflows. If you can see something that you're doing every day and you feel like it's repetitive and you don't really use a lot of creative processes or decision making, maybe AI can resolve that, right? A very simple example is I used to keep posting monthly paper lists on my GitHub. And for the first 4 months, I would do it manually, but now I have an agent that does it. I dump a bunch of papers that I read every day and I just give them a score on a simple Excel sheet. I give them a score. Oh, and I spend 5 to 10 minutes to do that because I've been reading this. And then at the end of the month, I have a simple workflow that looks at all of these papers, and it basically looks up archive, gets the abstract for that, generates a markdown file, and publishes it on my GitHub. So it's just a click. Things like that, right? It's pretty simple to implement it also. So if there's something that you're doing often and it requires some amount of knowledge, understanding, think of a way of automating it. And once you build that, you'll also start seeing issues with it. And that's when you can go into that process of learning.
That's so cool. Love it. Just before recording this podcast, we actually were talking a little bit about some of my background, which is I'm involved in the real estate space. I'm actually building an agent right now to automate and the analysis portion of the whole real estate investing, because there's some nuance that would never get right if a human is not involved, but then it's also very repetitive. It's like, I don't want to do this whole thing over and over again. And so that's like a perfect use case. So love what you said about automating something that you quote unquote hate doing and it's not very creative.
Basically, that's so cool. So in this process, Aishwarya, let's say if there's someone, let's say this person, whoever is listening to this podcast, is very interested in AI and understanding Gen AI. They probably know a little bit. They'll know more after listening to this podcast. And after that, what do you think they should go and do? Like exact things that they could go and learn from?
The way this is taken with a pinch of salt, this is what I recommend. A bit of self-promotion is that my 10-week course on GitHub is a very good place to start, because it gives you a mind map of everything that you need to learn, and it also in the right order. Like it starts off with prompt engineering and then builds on top of that. What are the issues with prompt engineering? How you can make it better, and then goes to RAG, then goes to explaining why RAG also might not work in some cases. One case that I was talking about, right, the real estate kind of knowledge analysis. Maybe you need a fine-tuned model. You never know. Maybe genetic LLMs are not trained on that, or cases where stylistic moderation or stylistic generation is more important, their fine-tuning becomes more necessary, right? I would really recommend folks to go check that mind map at least. Like if you don't read all of the course, it's totally fine. But then understand what you need to learn first. I was recently mentoring someone, right? And she came up to me and said, I did your 5 days agent roadmap. Like I put up a bunch of resources on how you can learn about agents and build agents. And then I said, okay, so did you know prompt engineering? Have you learned RAG? And she said, no. So that's why it's really important to not really go with all of these buzzwords that are being used and to first pick up basics at the application layer. I'm not asking people to learn how attention works. Like, I'm not one of those, purist AI scientists who say that if you can't code attention, you shouldn't be doing AI. I feel like AI is kind of gotten so large and there's space for everybody, but then at least pick up basics at the application layer. And then what I do is once you pick that up, the best place to get free education is deeplearning.ai. I mean, a lot of people don't know about this, but they have these 1 or 2 hour courses about pretty much anything about prompt engineering, about RAG, about multimodal models, about multimodal prompt engineering, about building agentic pipelines and all of this, right? With each of the theoretical concept that you see on my mind map, go to deeplearning.ai and do courses if you're someone who likes taking videos. And the best part is you don't even have to pay for the LLMs. You can access OpenAI APIs from their notebooks. If you had to build your own projects with the OpenAI API, you need to have credits. But here you can completely do it for free. And then it's really amazing experts who are coming to teach these things. That's pretty much how I would approach it. And once I'm done with deeplearning.ai, which is the basis, I can also pick up parts of the notebooks to build my own projects as well. Like, because you already have that base, you don't have to start coding from scratch. And that's where I would go to build my own projects, scale them, think of impact and how I could maybe serve this to an audience. Can I host it somewhere and solve any problem and things like that? That's the route I would take.
How long do you think is the right time people should allocate for this? I know a bunch of things online that talks about become good at using LLMs or learn this in like a month or, in 30 days or 3 months. Let's say the prerequisite is that they probably know coding and they are already a software engineer. What about them? And let's also talk about people who are probably just starting out. They are bachelors.
Yeah, there's a lot of parameters in the sense that how much time are you spending and then how quick a learner are you.
Oh, that's true. Let's talk about averages probably. So you're an average person, you're an average software engineer, and let's think about if they spend their entire time on it and then go from there.
I would say to pick up only the theory part of things to get a very broad overview of all of these topics, it would maybe take you 2 or 3 weeks. I'm not talking about the latest and greatest in research and stuff like that. Just to kind of understand what are the different ways you could use AI, it would take about 2 to 3 weeks and maybe another month or 2 months to start building projects and scale them and stuff like that. 2 or 3 months is probably the right time. And I feel like folks who have a good software engineering background can do it even more quickly and can also probably come up with prototypes even more quickly because at the end of the day, it's an API and you need to build stuff around it. If you're starting off from scratch, then there's also a lot of discussion on how good at programming are you and stuff like that. But I would still say a good 3 or 4 months should be enough. And just the fact that these days it's easier to learn things once you have a good roadmap of it. I know that there are tons of people who come up with their own roadmaps and all of those are not good too. But once you've decided on a roadmap, it's easier to learn things these days because one, there's also AI assistants. You can really have AI as your sounding board and learn with it. And there are tons of videos and all of that, right? A good 3 or 4 months is where you're in the position that if you read a new research paper, it's not a research paper, or let's say a research breakthrough or something like that. Someone came up with a new model and they say it's better. And after 3 or 4 months, you at least understand why they're saying it's better, right? Because you have the foundations to say what are the parameters that are important for a model, which essentially turn out to be maybe 4 parameters, which is like cost, latency, performance, and evaluation. Like you get a good picture of how different models fall into this entire ecosystem, what kind of applications you can build. But it'll take you maybe a good year or so to really read every paper and imbibe and understand what they're saying because there's so much and I myself can't keep up, so I'm not even in a good position to provide suggestions, I guess.
Makes sense. Right. So basically, if you are a software engineer and you want to become an AI engineer or basically get acquainted with everything AI in current world, you take courses like Aishwarya's Maven's course or deeplearning.ai. And if you spend your entire time in it, you probably take 3 to 4 months to get accustomed to building your own project around it. And maybe a few more months or up to a year to become really good at understanding what a research paper means and understanding what's cutting edge. So yeah, if listeners, you're trying to get started, you've got some roadmap right here. Because I really think, Aishwarya, not just for AI, it's for like any area right now, like high real estate or data science. We have so much information in internet right now, but the problem that we need to solve for all this information is to have a structure and the right roadmap. Because everyone has a roadmap, there's so much content, and it's so hard for someone who is starting out to know what to start, like where to end. So I think the problem in today's age is definitely not the knowledge or training that you can go take, but the problem is about the right roadmap and the right person that you can trust to get that roadmap and get that information. And I'm so glad we discussed that here. That could help people. Yeah.
And no, thanks for the Maven course promotion, but I was referring to my GitHub course, which is entirely
Oh,
free. You
okay.
can go check the mind map there. I feel like this situation is going to become only worse because AI is accessible to everybody and everybody is writing tons of content these days. And the noise is increasing along with signals. So it's really important who you follow or what kind of content you consume. I have seen a bunch of different people who have very extreme opinions about AI. Either like, oh, agents are just billions of dollars wasted, or agents are going to take away jobs and stuff like that. I feel like as long as you don't at least start interacting with these systems, you will have to depend on what these people are telling you just because you don't have enough education in this space. If someone's been using ChatGPT for the last 2 years, I'm sure they have a much more nuanced opinion about these things. They're not the ones who are, either fear mongering or saying all of this, isn't going to mean anything. So the first step for anybody doesn't have to be people in tech, doesn't have to be people who are looking to become AI engineers, is to start using this technology. It is going to become as prevalent as the internet. With that comes the issues with this technology also. Today, if you look up a bunch of stuff on the internet, I feel like we've conditioned ourselves to say that some of this is misinformation. I know that some of this is not true, or some of this is probably sponsored and not in my best interest. I feel like we need to develop that kind of a mentality towards AI as well. Like, it is useful, but then it hallucinates at times. It does a bunch of wrong things at times. And that only comes with usage and kind of, adopting this technology.
I think probably the first thing, like you said, you mentioned a couple of times, and I should probably talk about it like when I summarize things, right? I think the first thing that people should do is just start using ChatGPT for their regular workflows, right? Forget about building an agent, understanding RAG or what these LLMs are. Just go to chatgpt.com or, even Claude, and Perplexity there, and start using it and start challenging it. Then you'd understand where it is really good at, that you'd be super surprised with, and then you also definitely will understand where it's not that great at, and you do understand the power of you, right? The power of you, the context of you, the domain knowledge that you bring in is going to be really important. Whatever the systems that might come in, there are going to be some facets of the skill set that a person possesses that are still going to be relevant, or in fact, it gets even more important, I guess, because there are definitely some areas that can't get picked up, and you fill in those gaps, and those gaps need to get filled to actually have a great solution.
Yeah. Totally makes sense.
Yeah. Hey, Aishwarya, one question for you. Is there an application of Gen AI that you've worked on that would surprise people?
I think the agent for research summary was something nobody expected. People thought I was actually writing these research summaries, not research summary, but the research list
Oh, yeah.
on
yeah.
my own.
Yeah,
Summaries,
that's actually pretty cool. That's actually pretty cool. So when did you do that? Was it recent?
It's been about 3-4 months. So everything, basically, it's just a markdown table with the title and the abstract, and then which class of topics it belongs to. However, I try to automate some parts of my content generation. I feel it's still not there because it gives a very generic and somehow, for the lack of a better word, cringe looking content. So I feel like I don't know, at some point, maybe I could fine tune something on my own post to kind of try and understand that. Something cool that I really used recently was this. There are a bunch of these products that do it, which is they automate literature survey generation for you. So if you're a researcher, the biggest pain point for most researchers is to find literature survey, right? What are these other papers that are doing something similar? Have they achieved better benchmarks and all of that? I think there's this website called GenAI, like GenAI, that kind of automates a bunch of these things for you. Like it is a search system for archive papers. If you throw your idea and also what models you're using, what benchmark data sets you're using, it comes up with a bunch of papers that are in the same domain. It does citation management and all of that. So that's probably something a lot of people have not used because they're not researchers, but it's pretty useful. And NotebookLM, I use it for research paper understanding. It's much better than ChatGPT. So if you just upload a research paper and kind of chat with it, it answers questions like, what are some surprising points about this paper? What are some bold claims in this paper? And ChatGPT now, it doesn't do that pretty well because this is a classic issue with RAG, that if the query has really statements that are not semantically matching. For instance, like how RAG works is when you say, what are the surprising points in this paper? It tries to look for the words surprising points and all of that. But you need this innate knowledge of understanding what does surprising mean in the context in order to answer that question. And NotebookLM does a fantastic job at that.
Oh, I love this example that you gave. Before I go into one example that I want to give, I want to point out for people, especially in the context of us talking about wanting to understand AI or wanting to get into this. So whatever you're talking about is actually great, right? Take the most popular, I think there's this very popular Transformers research paper. Put in a research paper into NotebookLM and try ask it really dumb questions, and probably that'd be a great place for you to learn stuff as well. So use AI to understand AI.
Exactly. Yeah. If you're trying to understand complex research papers, NotebookLM is the place. For me, again, I don't endorse any particular LLM because they all have their pros and cons. I feel like Claude is amazing at code generation. So if you're using Cursor or Codium, like having Sonnet 3.5 works best. I use ChatGPT for creative writing. I feel like it writes in the most humane way possible. The other LLMs, you can understand it's AI generated. And then NotebookLM does an amazing job at research paper understanding and summarization. Somehow tried to get off the waitlist for VO from Gemini. I've been hearing really cool things about it. But I really hope there's this future where there's model unification, like all models are pretty much good at everything. But I think that will happen soon as well. But at this point, I'm kind of this person that picks up different APIs for different stuff.
I think having that knowledge of, hey, this model is good for this model is good for that, is like in itself a very worthwhile exercise for our audience. Like, go to NotebookML, type this prompt about this research paper, and effectively recreate the route that you've taken, Aishwarya. Do the same with ChatGPT and see how different the answers are. And then that'll give them, hey, these things are just different. And one is good at this, one is not great at that. And then you start building pattern matching recognitions on how should I be using what for what.
Makes sense.
And asking them the right question is so darn important. So that's where the prompt engineering comes in, I guess. So I was listening to this very cool podcast on dopamine and, how it's affecting people's brains today. And this was like 2.5 hour long podcast. And we had this rule among our friends that if we share big podcasts, you need to share a summary of it. Because I'm like, why are you sharing all these things? And I'm like, okay, let me use ChatGPT for that. And the summary it gave me, so I got the transcript from somewhere, like another tool, and used that to get a summary. It didn't do a good job at all because I was amazed with how amazing the podcast was and hence wanted to send it. But it just gave me the most generic summary there is from the transcript. Then I talked about, hey, mention this code, mention this particular pain-pleasure balance that they spoke about that was never discussed in any other podcast before. It was probably giving me the most summarized information that everyone already knew, but the podcast had a differentiator in it that it didn't cover in its summary. And I had to give it pointers because I listened to the podcast. And then I asked for the summary. It did such an amazing job at giving me the summary than me writing it myself, right? And then I pasted it, and then it had so much more engagement versus the previous summary. This is like a regular, simple use case that you chat with your friends, guys, you share content, like how could you use and understand the importance of how do you talk with these LLMs?
Yeah. Quick endorsement for something that I've used recently is there is an AI agent product. I don't know. It's a very simple workflow. It's called PotSmart. It does exactly this, right? You just
Oh my God, I
click
should
on
have known about this.
you just click on a podcast and say, can you summarize that for me? It summarizes it and it sends it to your email so that you can check it out. You can kind of mark a bunch of things and it just keeps sending it to your email, the summary. And I think that does a much better job than all of these very general LLMs, right? Maybe because they've prompted it so well, or they've maybe put a layer on top to be very good for podcasts. So that's a nice app if you're into podcasts for summarization. Yeah.
We
Oh,
absolutely
I'd
need it
use
for
it.
this podcast. We need it for this podcast.
Yeah.
But I don't want people to use that for our podcast. Hi, I want people to come listen to our podcast. But that's okay. It's okay in the vein of like understanding what to use in today's world. Yeah. Yeah.
Aishwarya, I think in a previous talk you had, I think I remember you said something about prompt engineering is not as important going forward because we're going to have a bunch of innovations to mask that away. Could you maybe tell the audience a little bit about how much do they need to learn how to speak to AI nowadays versus in the future?
Yeah. So one, I was saying this from a very enterprise kind of a view, not for a common user, because at this point for enterprise use cases, there are a bunch of different tools that automate or make prompt engineering much easier for example, DSPY and all of that. But that does not mean that everyday users need not have to learn it. Again, like the base of all this is prompt engineering is still a bug. I don't think it has to be that hard to talk to LLMs. But at the same time, think of it this way, right? We as humans, when you talk to your friend versus your colleague versus your child, you talk in very different ways. And you're essentially doing prompt engineering there because you understand how these people react to things. So getting that far with AI is also pretty important. I was kind of against these people who sell like 1,000 prompts for ChatGPT to get this thing done and stuff like that, right? You don't have to use those things. It's as simple as talking to a human, and the more you interact, you understand how to frame questions. That level of prompt engineering everybody should learn. But again, I don't want to put that term on top of it that learn prompt engineering, which makes people think that it's a completely different skill that I should be picking up. It's as simple as interacting with someone and just tailoring the conversation to make sure you get the most optimal responses. And I was saying prompt engineering is dead because it's getting much easier and much seamless over time. For instance, when GPT-3 was out, if you asked it a math question, it would always come up with the wrong answer. But now if you ask any math question, I think 4.0 starts writing code or something. It pulls in some tool to do that, right? You don't have to specify that. So that way, the barrier to using these systems has become much easier over time. That doesn't mean that, you shouldn't learn how to interact with these systems. I just don't want to put a tag of prompt engineering is something that you should know to talk with these systems. And that's where I was coming from.
So basically, Aishwarya, now, so in the context of the question that I prompted, right? So prompt engineering in the past, especially in the ChatGPT 3 world, where it was like, you need to not only know what you need and how do you communicate what you need. So the communication aspect of it, plus what do you tell LLM to get, how do you get that answer? Like you have to also tell the exact details, exact steps on do this and do this and do this and do that. Currently, it's smart enough and intelligent enough to do that itself. But the communication aspect of it, you just need it for your regular life. Like you said,
Exactly.
you need it to talk to people to make sure like you convey what you actually want from the conversation or what type of problem you want to solve. So that probably still stay the same. So basically that human intelligence of the right way of communication still holds true even for AI engineering. But the engineering aspect of it, of how many times the exact specifics that you have to give, probably that's gone away, right?
Yeah. That can be pretty much automated. And I was also coming from a view where, so as an enterprise, when you're trying to build a solution, you want to experiment with different LLMs, basically the ones that meet your constraints. And as of today, it's not very easy to just seamlessly swap these LLMs because each of them are kind of designed a little differently. And there are online resources to automatically do that. You don't have to be manually sitting and making changes. Maybe all of my suggestions were for people who are already very used to prompt engineering and who know to do basic things. But for people who have never used AI, you still need to learn how to interact with these systems. And you will learn that by just using. There's no need to read a bunch of things or, take a course or anything like that. Just start interacting with these systems, and over time you will start understanding these patterns that work with LLMs.
What I'm hearing here is, Aishwarya, everyone should know, well, the language that people should learn, English and how to speak to AI.
Right. Yeah. Yeah.
That's awesome. I love how actionable things are here because honestly, as you said, with the amount of noise out there, especially the amount of content on YouTube, on different podcasts, on different mediums, it's so easy to get lost of, hey, this is what I should learn next, or this is what's going to be useful for me. And then like once you get into a rabbit hole of certain direction, you just can't pull out because there's way too dense. One question for you. So we talked quite a bit about the applications of Gen AI, how people can get into it, certain aspects that don't work well, and how people can experiment with it themselves. What is one thing in your very deep career at the forefront of the Gen AI research? What's one thing that you've never shared publicly that might be helpful for the audience to know? Or maybe one thing where maybe people expect AI to be really good at today, but it's actually not, kind of like a hype that you want to squash given you're a realist?
I think a bunch of people have very, I feel like they think AI is this black box that can automate different workflows, but regardless of what kind of AI we're talking about, right? Like previous traditional machine learning models or like deep neural networks or generative AI or agentic AI, at every one of these innovations, people started thinking that these are going to be really big breakthroughs. But I feel like the data is still very important. I feel like even today, I spend more time looking at the data that goes into these models rather than the models themselves and thinking about which LLM will be able to do better. Because real world data is really, really messy. And then once you get into it, you start understanding that. Because sometimes there are annotation issues. There are issues that seep in from the pre-training to the evaluation or to the generation part of these LLMs, right? So regardless of what AI can achieve and how smart it gets, I feel like if something cracks, if there are issues with your application, always go back to data and you'll really find some insights. And yeah, as data scientists yourselves, I feel like you guys will really resonate, and that's what I've observed over time.
The garbage
Thank you for
in,
the plug.
garbage out mantra.
Yes, yeah. And no fancy AI can do much about it, right? Because most of these systems are pretty much consuming all the data and spitting out averages of what they've learned. So if you're, garbage in, garbage out.
Thank you for plugging in data there. So, Aishwarya, maybe we are getting close to the end of the podcast, but I'd love to understand what is the workflow. You talked about data, you talked about understanding what type of model you choose and why do you choose that. There's RAG if you want to use RAG, and if the problem space needs, and then there is evaluation at the end. So, would love to understand different aspects of this. And maybe some tools that are currently popular in these areas that people who are new to this would get some idea when they read some stuff from people.
Yeah, the way I would approach any problem, let's say a simple thing like a company says that we have tons of documents and we want to develop a chat with our documents kind of system, right? The first questions I would ask is, what's your budget? Like, what's the cost you're looking at? What are your latency constraints? What are your performance constraints? And that's how you also narrow down what kind of LLMs you want to use. Sometimes there are applications where there's a human in the loop component, so the performance is not really a huge factor. They're okay with having some errors because there are humans who can kind of verify them. Sometimes it's a real-time application. So these are parameters that we use to narrow down on what is the LLM. That's the model side of things, right? And then we also look at their data, try and understand if there is something that really stands out. Pick up an evaluation set for this chat with your document. We kind of pick up logs from previous conversations if they had a chat system. If not, there is need of synthetically generating that, and you need to talk to subject matter experts to really understand what kind of queries do you expect and how can we design maybe a synthetic data set to evaluate our system on it, stuff like that, right? And sometimes data is also pretty noisy. So we do some kind of data analysis to understand that if I ask a particular question, they're probably conflicting answers in different parts of your database, right? There are two answers to this. So how do you do conflict resolution of those kind of things and things like that, but very specific things to the data. That's the data layer, the model layer, synthetic data generation, and all of that. And that's when we would think of which usage paradigm to use. That's the application layer, which is if it has to do anything with using external data source, and that external data source doesn't really fit into context, then it is a RAG solution. That's where we start off. And then build on top of it. Like sometimes RAG is also not enough for some enterprises, because think of an enterprise that has knowledge stored as a SQL database, knowledge stored as PDF documents, knowledge stored as videos, and you need to build a chat system over all of these three modalities. Then probably you need an agentic pipeline here, right? Because the agent will make a decision as to what to do, whether to look up this unstructured data source or whether to generate a SQL query and stuff like that. And then once you do all of this, we start evaluating it on the responses we have and maybe do some testing with real audience, right? Create a prototype and allow people to test it. That's when you start seeing newer patterns, and sometimes it's possible that there are design mistakes that you have made in terms of just choosing the wrong distribution of data, or maybe there are issues that you have not encountered and stuff like that. And sometimes we also realize that there is a necessity to fine-tune these models because they're only getting to a certain accuracy with the RAG and agentic workflows and all of that. Maybe the domain is so niche that the LLM is not good enough at doing that. That's pretty much how we do it. And then we build in an observability pipeline as well, like logging everything that's happening. How many LLM calls is this particular thing taking up? And also some form of continuous monitoring. There are companies that use LLM judges in order to evaluate LLM responses because they want some automatic some confidence score as to how good these responses are. So we put in that for some companies. That is pretty much how it's a very ML workflow if you really think
Exactly.
of it.
That's
Right?
what I'm trying to think.
There
Yeah.
is nothing new in this. Just the kind of challenges you face are a little different, because if you think of an ML workflow, it's pretty much predictive. So you can always come and say that, oh, this is the F score, this is the accuracy I have.
Yes.
But for generative AI pipelines, think of a chat system. How do you really understand if the response generated was actually semantically right? Because there are 100 different ways of phrasing the right answer. So you really need to think of metrics, simpler previous keyword metrics, or like unigram, bigram metrics like blue, rouge. These are NLP metrics. They don't work anymore. That's where, maybe you need to bring in some fuzzy matches. You need to bring in some semantic representations, or you need to bring in an LLM to judge if this is the right response. There's also metrics we use to identify the quality of data. Like for instance, in a RAG pipeline, there is a test you do. It's called noise robustness, which is if I give you a lot of noisy context, how well is the LLM able to disambiguate that and still find the right answer? And all of these
That's
metrics
amazing.
are very these are very context dependent. It's possible that an enterprise has really clean data, and if this metric was, 90% and above at my first score, this is not even something I want to monitor. But then you need to be coming up with innovative ways of making sure that you have enough feedback from your product that's online so that you can do something actionable. This continuous monitoring kind of a loop.
So I was going to ask that. So from what I heard from you and also my own experience and what I hear in the research as well, is evaluation the hardest part in the entire thing? And is human feedback, like how much of the synthetic data and how that LLM judges, which is not human, right? The judges things. Like what is the percentage of it? We are still dependent on a human saying it's a right answer versus not to keep iterating on it, right? So just curious about that aspect.
Yeah, evaluation is harder because of multiple different reasons. One, like I said, it's not the traditional ML evaluation. And the other is also that a bunch of industries who never used AI before are trying to use AI. For instance, these real estate contracts that I was referring to, or like people in supply chain, companies in manufacturing, these people don't even have an evaluation data set. They don't even know what it means to evaluate. Like if you talk to tech
Yes.
companies, they really understand how this ML workflow works. But now AI has become so pervasive that you are teaching a bunch of different use cases. So how do you convince these people that AI will solve issues for you when they don't even have metrics, or they don't even have data to kind of give it to you, right? That's why I think evaluation is harder both technically and operationally. And in terms of LLM, go ahead.
No, I was sorry. I was going to say basically domain expertise also matters a lot here, right? So someone who understands the LLMs and also understand the domain would be the right person to help us figure out what would be the right, answer here and things like that. Is that true, or do
I
you
would
think?
still think a domain expert doesn't have to really know these things very well. An AI engineer should be able to ask the domain expert the right questions so that they can
That's
kind
true.
of translate it into AI problems, right? Because if you need a domain expert in a supply chain kind of system to learn AI, that's not something that's feasible. Even when you build LLM judges, the ideal goal for you is to build a judge that can mimic the domain expert. And in order to be able to do that, you need to get all the gaps filled. The AI engineer should make sure that they've asked enough questions and they've laid it out well for the subject matter expert to give feedback so that you can calibrate your LLM judge. So I feel like all of that responsibility is on this developer who's building the product.
Yeah, I mean, there's also the component of subjectivity here, right? For example, hey, if I build a chatbot and the output and I need to judge it, I mean, it could be good, it could be better, it could be best. There's no threshold of if this is good enough.
Yeah. I think that is a skill that you need to pick up while doing evaluation. Turns out that LLM judges, again, this is just a quick fact or to the is that LLM judges do pretty bad when you ask them to score on a Likert scale, right? If you say, give me a score between 1 to 10 and you run this 100 times, the variance is pretty high, which means LLM judges have no idea of what these numbers mean. A good AI engineer who knows evaluation will always try to design metrics which are like yes, no kind of metrics, like binary metrics. And LLMs have a bunch of other different biases. They also have this verbosity bias, which means they score responses with, longer responses higher as compared to shorter responses. So as an AI engineer, you should be aware of all of these things they do and design metrics that avoid these pitfalls.
It's almost like data labeling exercise, kind of like back in the days where, hey, I have this output. Is this better than this output? And you just do like yes or no, no ambiguity.
Right. And sometimes it also happens that these LLM judges align with human judges, but then their reasoning is completely different as to why they align with human judges. Then it becomes really important to also ask your human judge, was this reasoning trace the LLM has printed also similar to what you're thinking? Because it's just possible that by chance they've arrived at a solution. Yeah, typical machine learning problems, I guess, but then kind of translated into the GenAI space.
So I think this is the end question. So we keep hearing, right, that AI is going to take away jobs. So I have this future prediction. Let's see if this is going to work or not. But I hear AI engineers today do everything around communicating with people, making sure they have the right metrics, making sure they're using the right models. And there are like so many skills that I've heard. And today, all of them come under the umbrella of an AI engineer. Probably in future, in like 5 years from now or so, we'll probably have a different name or a role for all these aspects of AI engineer that we have today, right? Instead of all of them being AI engineers, we'll probably have, I don't know, LLM judge engineer. I don't know, I'm just making up a name here, but things like that, right? People who are the who devise metrics. We currently, data scientists, we have a product analytics area, and data scientists and all the biggest aspect of them is product and experimentation. And I can definitely imagine the metrics and, the impact of the domain for that particular use case. I could definitely see like a role shaping up there if the other roles kind of die down or there's less work in other roles.
Yeah, I mean, I have a different prediction. You take like a horizontal approach to this. I think it'll be more vertical, which means there will be AI engineers, but then people who are very good at solving problems in a particular domain. Because I feel like every domain has very unique issues. And then when you start solving problems in that specific domain, for instance, like I mentioned, these intelligent document processing, right? That itself is a huge domain which comes with its own set of issues. I feel like we'll have image AI engineer experts or things like that. I think it's more of there'll be a vertical thing because you really need to understand the space very well in order to be able to design metrics for that space or to be able to design solutions in that space. And it's also hard to build breadth in this case, right? Because it also has a lot to do with the nuances in that domain. I don't know. This is what I think, but
Probably what you're thinking is more apt than what I'm thinking from outside. But maybe there'll be like a horizontal and vertical, a combination of that, right?
Yeah.
Yeah, that's so cool. I think we are coming up on time here, so maybe one last question for you, Aishwarya. How can people find out more about you? How can they connect with you?
I write a lot on LinkedIn. That's where you'd find a lot of content. So LinkedIn, and I also have I have my newsletter. I also have a bunch of YouTube videos and all of that, but LinkedIn is kind of your channel. You can find all of that there.
Cool. Awesome. Yeah. Connect with Aishwarya, and for all the listeners and watchers, thank you for listening, and we'll see you next time. Don't forget to like and subscribe and comment and do all of those things that help with the YouTube algorithm so that we can bring you more content like this.
Thank you so much, Aishwarya. This was amazing. I myself learned a ton, and I'm sure all these listeners would have learned a ton as well.
Thank you. Thank you for having me.